try. Hello, everyone. My name's Bill Rowe. You'll find me all scattered across Apache HTTPD, APR, and other projects as William A. Rowe, Jr. That's not being snooty, that's just disambiguation because I was already the second Bill or other Bill by the time I got to the APR and HTTPD projects. Today we're going to talk a little bit about the actual application of some of the SSL concepts that Sander was just speaking of with respect to the current shipping release. I know many of you probably today have a lot of instances of Apache 2.2 rolled out, and hopefully you have no remaining 2.0 instances whatsoever. Now all of our activity is being driven at the 2.4 release. So if there's anything that you find interesting in the evolving state of SSL cryptography or filtering or proxy for WebSockets or any of these other features, you're going to have to go to 2.4. There's just not going to be anything new, interesting that'll ever happen again on 2.2 other than a few security releases. Speaking about the topic of TLS on HTTPD, our guidance is changing annually. It used to be that we were on about a 5-year cycle of new guidance rolling out from NIST and other organizations whose guidance was surprisingly correct in most cases to you, in spite of whatever apparent conflicts there might be there in terms of both protecting sites and apparently sniffing traffic themselves. But the NIST guidelines were pretty well set up, and in 2010, we did a complete turnover. We were guided that we couldn't do MD5 hashes anymore. We were guided that we couldn't do 1024-bit encryption or anything that resembles that. That would be akin to a 128-bit DH key or whatnot. And so the NIST, National Institute of, or the National Institute of Standards and Technologies, publishes guidance, as do a number of other national standards bodies. But unfortunately, the pace of change since 2011 has been truly chaotic. Roughly every 6 months, we have brand new guidance. Things that were theoretical attacks in 2004 are now proven attack vectors here today. So what I'm going to try to do is take you through our docs and the configuration of Apache in a modern sense, and in a way that hopefully you can continue to follow our evolution as Apache 2.4 is going to continue to change for the next 6 months and year as we start adopting these features. The other problem that you're going to find is that all of your web references, everybody has their favorite queries on Google or whatnot to get a quick server up and running. And you're going to find that the vast majority of that information is incorrect now. So I'm going to try to provide a little bit of guidance to help you flag the good articles from the bad articles. And the other point that I believe that Sander did a pretty good job raising is that plain HTTP is actually nearing extinction. It probably has served the majority of its useful life. There's very little content out there which doesn't suffer from problems if it's been compromised by a man in the middle, but with the proliferation of Wi-Fi access points and other services, we can't actually, HTTP is becoming useless, and even with respect to passwords. I mean, it became pretty clear to all of the major providers of social media services that they could no longer even have an HTTP portal whatsoever. So we're going to be entering in the next couple of years, I would say, a scenario where almost every website, of significance has an HTTPS portal, but also that we're going to lose the HTTP access. In fact, you may be familiar with, if I remember the order of my tabs, this initiative that the EFF has been driving for several years now of just making SSL, the de facto protocol, HTTPS, the de facto protocol all the time in every application. So let's decide what we need to accomplish. Because when we're configuring Apache for TLS, for SSL encryption, we're going to have to make some sacrifices. And you're not going, we don't get to choose we don't get to choose 3 of these 3 items. We don't, in some cases, get to choose 2 out of 3 of these items. So what do you need is your priority on confidentiality, ensuring that the traffic cannot be deciphered either by in real time or in the far future, given terabytes and petabytes of historical traffic. How much of it has to be confidential? For how long does it have to be confidential? Or do you need performance? And performance is becoming less and less of a consideration now that you can ramp up a larger cloud, provision more servers. Performance may not be as critical an issue as it was before. We also have much faster hardware, much faster CPUs. If you're using the Intel AES-NI extended instruction set, really basic, the basic encryption that occurs for the majority of the conversation in an HTTPS conversation is going to be extremely optimal, and it's going to be minimal amounts of CPU load to have that dialogue. So how big a factor is performance in your configuration, in your particular rollout, and how much of an issue is compatibility? And we're going to have to decide to sacrifice at least 1, if not 2 of these things to really take advantage of TLS in the year 2014. So some of the questions that you can ask right off the bat is to evaluate the scope of the confidentiality. What is the value of deciphering the communications that's being secured? If it's a social networking site for updating status and the rest, is it sufficient that it can't be reasonably decoded in a year or casually decoded by interloper, or is it something that is of national security importance or corporate security or political dissidence that you don't want this to be deciphered for the next 10 or 30 years in spite of some very enthusiastic people going after the traffic? And notably, what is the return on investment? We now have other ways of metering the hardware capacity in your fingers, at your fingers. Could it be more cost-effective to do Bitcoin mining than attempting to break your session with your bank? Is historical information on those accounts 5 years from now going to be as sensitive as it would be today if they could actually perform transactions by impersonating a current user? So what are we going to trade off for performance? In general, if you can trade off performance, we can use some very traditional ways of ciphers that I'm going to get into in a moment, but with a very heavy additional cost to do forward secrecy. If you don't want to give up performance, then we're going to be very restricted in terms of which ciphers we're allowed to, we can actually take advantage of that are performant, that do deliver something equivalent to the cryptography we've done last year. And finally, do we want to trade off for compatibility? Because if you can trade off for compatibility and state that your service is important enough and the confidentiality of your service is important enough, now you need to make the election. Perhaps it's time to actually kick off all the IE6 users and refer them to upgrade their browser rather than continue to put up with people who inherently introduce insecurity into your specific connections and perhaps your wider organization as well. So we'll start at protocols because that's the simplest thing to do. And that directive hasn't changed a whole lot in a whole lot of years, except that SSL v2, as of the current version of Apache 2.4, doesn't exist. We've simply deleted it from our collective memory. You've been told not to use this for the past 10 to 15 years. Now we're enforcing it. It isn't there. The question becomes now, is it time for you to disable SSL v3? And that's going to be a call based, again, on the security of your particular deployment. Even within the TLS, now of course TLS v1, that we've used for 10 plus years now, but with the evolution of 1.1 and 1.2, now we can actually start to mitigate some of these beast and other attacks that were based on taking advantage of omissions in the design of the protocol itself when SSL v3 was out and when TLS v1 first rolled out. What I should point out is that we talked earlier in the last session about OpenSSL 101 and specifically 101G, the vulnerability that was just disclosed yesterday. Now what you have in 101 is that you have support for the TLS version 1.2 protocol. If you were using 098, you don't have this set of features. So for that reason alone, although 098 appears to be much more stable, much less activity happens in terms of new discoveries of vulnerabilities or whatever, and in fact, the problems that we're seeing occur are in the newest code in OpenSSL. However, that also means that we can't mitigate protocol level errors that have been around for quite a while and are very well documented. So speaking of ciphers, I'm going to spend a minute and for the rest of this session assume that you're on not only HTTPD 2.4, but you're also on 1.0.1. Let me find my, that'll be interesting. Surprised to have a 1024 pixel projector in this day and age. Okay, let me just tweak this protocol or this setup a little bit so we can see the whole screen. Yeah, we'll have to do something a little bit smaller. I hope it's still legible to everybody. So the OpenSSL tool itself, and Apache is largely dependent upon the OpenSSL project and what capabilities they give us. And just as a forward reference, some of the things that I'll talk about, you may ask, well, can I disable that feature or can I have some extra control? And in fact, Apache or OpenSSL 1.0.2 is very close to coming onto the scene. And you will probably want to adopt that fairly rapidly after we finally see it emerge from beta. In fact, beta 2 should be out extremely shortly with the fix that we just found for version 1.0.1. And at that point, you may want to begin experimenting with it, especially on your development machines, because it's going to give us a finer level of control over some of the new features. So within this, let me give you some, offer you some illustration here. If we have an extremely old version of OpenSSL, or even some of the more modern ones, here's a RHEL 5, it just happened to be one of the VMs that I had mostly handy for today. So this is certainly not current, but if I say I would like to see the crypto ciphers that are supported by a particular version, whichever OpenSSL you have, you can find out exactly what is supported. Now, one of the things you're going to find is that different vendors, different OS distributions have enabled a different set of ciphers. But the other thing I need to point out here that's even more important is that this is the natural order list that the OpenSSL project and that particular distributor have decided to apply and prefer one over the other. And these can be for a number of factors. It could obviously first be for security. Secondly, it can be for your performance, and only your distributor is going to know this well. So let me just make one quick change here to look at a very modern version. And bring us up to the current decade and the current year. So here we have 101G, and within that, if we look at the ciphers, Here we have an entirely new set, and of course the very first thing we're going to do is prefer to have a conversation using the TLS-1.2 protocol rather than trying to speak in SSL v3. So let me take you through a couple of things relative to the ciphers and keys and how we're currently doing things in the Apache project. So we have the big list, and you are probably familiar, if you're in this talk, with the SSL ciphers directive, but if you're not, just to take you there for a moment, the SSL cipher suite directive gives us the option of specifying precisely which ciphers we would like to use, which we consider are secure enough, and which we consider provide reasonable performance for our application. And what's interesting here is that we're using exactly the same formatting for the selection of ciphers as the OpenSSL project itself. So if I take our current recommendations, and this gives you a list of many of them, but realize that we're not the official docs on this. You want to go back to the OpenSSL project docs to find which are sometimes few and far between, but in terms of specifying a precise list of ciphers that are going to be reasonable and acceptable. So if you take, now there's an important note here that we've gotten rid of all null and export grade ciphers at the same time we got rid of SSL v2. So we've been readily trashing things that you should never have touched. So always, mod SSL is going to unconditionally prepend getting rid of all the A-null certs, all the E-null certs, all the export grade certs. So if I take our default config, and you can generally get a sense for what our recommendations are as a project by just following our default config. And if I can come to that back on the session here. And if you haven't been around Apache and you're just going to jump onto 2.2 and 2.4, and you're finally getting around to it, you're going to find that the structure has changed a little bit. We've tried to simplify httpd.conf, and what we have done is drawn in a lot of small configlets, and those configlets are meant within the extra directory, meant to help you get started. You can certainly continue to use one monolithic config file if you'd like to, and use these just as examples, or you can use our include directive and bring in either these snippets or a hierarchy of snippets that makes sense to your application. So here's our default cipher suite. We're only going to look at high, medium, and as you note, there's really no reason for A-null to even be there based on what we just talked about. And we're going to get rid of MD5. And I'm going to just show you what that looks like. And then we can get into a little bit of what does that actually tell us. So let me start a second console here. That's really not the way I wanted to do it. So I can take that exact text and ask the exact question that I did a moment ago, except this time I'm going to pass it on the command line as, yep, I'm going to do it this way. Every once in a while it insists on not honoring my clipboard. Yep. Oh, yes, yes. Escaping exclamation marks on the bash shell. But let me just show you medium high for the moment. So, and we're back to this problem. That should be right. That should be right. The which? Oh. This is going to tell us a number of things, and these are the decisions we're just going to talk about in a minute about doing perfect forward secrecy. But the very first question is, how are we going to negotiate a key, and what is that key going to consist of? This is a very short conversation. This is the initial handshake that occurs between the server and the client. And this is where we get into a lot of trouble with performance. The main body of both the request and the response is not the pain point in doing SSL encryption. It's this initial handshake. So what we have here is RSA certs and DSA certs that are elliptic curve cryptographically mapped. If you're familiar with RSA, the concept was very simple. Let's use the product of several primes that are so large we're not going to be able to factor out what those two primes are in any reasonable amount of time. With elliptic curve cryptography, we're doing the same thing, only using Fourier, I think it's Fourier math, is it exactly the phrase? But we're basically using another mapping system in order to efficiently, we want this to be efficient in one direction, be able to do this multiplication and division if we're in possession of those secrets. So, in this case, the most efficient, by everybody's, if we're going to do perfect forward secrecy, the most efficient solution is going to be using the ECDHE key exchange. And in doing that, we'd like to use an ECDSA cert. And we know most of you don't have an ECDSA cert yet. Perhaps that becomes a priority now that many of us are going to be rekeying our servers, that we actually provision both. But the RSA key, of course, is what we're most familiar with. But rather than continue to use the RSA key in the way that we've previously exchanged it, using DHE, or I can go all the way down through this list. Yeah, that's what, sorry, let me go up one page. Instead of using, DHE for our key exchange, we'd like to do something that can't be easily deciphered, that is truly secret between the server and the client. And as Sandra noted, you can't even sniff this traffic at your router point. You're not going to be able to simply decrypt based on happening to know the server's own secrets. So here, we're going to try to collapse this list, and using a little bit of information such as whether we have SSL v3 enabled or not, we're going to continue to squeeze this list down in this sort of a format. Let's say we're not going to allow, and the backslash is just because of the command line, but let's say we're going to prohibit v3, take away the protocol. Invalid command. Process rule string. I'm going to try one other thing. Just for fun, I'm going to change the quoting. Yeah. Less of a headache. So, and we can continue to squeeze this down and get rid of the most inefficient ciphers. So this is our, as I say, this was our current recommendations. And there is an error in that, as you just noted, which I'm glad I discovered today, since I'm inflicting it on people in a week. Shoot. Where did we go with this? So going back to my test host config, so as we noted, we have to do high before medium? Yes, high before medium. And here is an example we provided, and I think we may have removed this from the 2.4 distribution. Somebody had offered up a accelerated cipher suite that would be a little more performant, and you'll see here that we are preferring in this list an RC4, which is an extremely fast, older protocol, versus the other high and medium ciphers. What we do once we've decided that there's a particular cipher that our CPU, I mean, if we have the AES-NI CPU instruction and we want to use that, then we're going to want to favor this AES-128 SHA. We're going to reverse the order of those two. But what I need to point out is the second line, and this is not the default, but I believe that most of you who are working with servers are going to want to enforce and simply, if it's not in the directive, just add it immediately after your cipher suite and put in there that you want SSL, mod SSL to honor our list before they listen to the client's preferences. Because the client, you're dealing with so many more different agencies. Really, we have a very limited number of servers. You might look at it and say, well, we have Nginx, and we have IIS, and we have Apache, and a handful of other proprietary. That doesn't matter. That's a tiny number compared to the number of permutations of the browser releases that are out there and of the other user agents that are out there. So you're probably better off not letting user agents make this choice for them. They'll still present what ciphers they're capable of. You will still present what ciphers the server is capable of, but then the server is going to make an election, and that election is going to favor the performance, and we know our machine, and our machine has to deal with 4,000 concurrent users. Their desktop machine, okay, it might not be the most efficient thing on their desktop, but we frankly don't care on that count. So coming back to the slides for a moment, so I stay on task. So we can get a simplified list by simply crunching that down, whether we take the default that HTTPD recommends or some lists that I'm going to point out in a moment. And we're going to make sure the server is enforcing them. We're also going to rethink about our certs and keys, because if we put in an ECDHE key, it's like a traditional Diffie-Hellman key. It's like a traditional DH key. We can't use DH keys whatsoever in a forward secrecy deployment. We can use RSA keys, which have been re-encoded and are being transported over EC, or we can have a key that was designed this decade for that particular application. And I know that I think every major key vendor now has an ECDHE product solution out there. So it's definitely better than RSA. But when we talk about RSA, the other thing we may have noticed, some of you probably noticed, but I'll call it out for everyone else. When we looked at that list, at the very end of that list was a hash. And that hash becomes critical because we're basically going to trust that the hash of the cert is the cert. And when you start giving an identity like that to something that you've you've absolutely trusted that this certificate is what it represents, and if you come down here to this item, 3/4 of the way down the list, and we find a DES CBC3 MD5, if we don't trash the MD5 certs, people are going to trust that that 80 bits represents your server, even though the computation of trusting that public key was far more sophisticated than an 80-bit number. And that 80-bit number is nowhere near 80 bits, because we've proven that it has about an effective 56 bits of entropy. So it's a horrible, horrible problem. So is SHA. I mean, you'll correctly observe that SHA got broken down from 128 bits down to really an effective 112 bits. And now it's far less than that. So even as the number of bits drop, because we find out that we were imperfect in putting entropy in and seeding these values, we're now suggesting let's use a 384-bit SHA by default. You can't do this with SSL v3. You can't do this with TLS v1.0. So you really need to start picking up SSL v1.2 in order to take advantage of the security that this offers. And is there a reason today to even have an MD5 key? I mean, we're really talking about the IE browser for circa 2003, and everybody knows that that version is quickly on its way out. And it's not exactly difficult for your users, consider this, for your users to obtain another browser in spite of whatever older hardware they have. Maybe a Firefox, maybe a Chrome, maybe whichever, depending on their architecture, they can obtain another browser. So we're gonna want to avoid that MD5, and in fact, that's what our configuration does. If I say, now that I've got the syntax right, I can get rid of that danger. And now we're going to go down to a 256-bit hash. In general, I'm trying to remember the rule of thumb, but your hashes and your AES encryption keys hashes are twice as weak. So if you have, for example, you can see here, we have a 256-bit hash with an AES 128 bits of encryption. And so what we're basically saying is they are roughly equivalent. You wouldn't want to secure an AES 384 connection, which is overkill, frankly, with something trivial like SHA-256. So here's a list of recommendations as implemented in TLS v1.2. And you can see they are all TLS v1.2 certificates left once we've gotten rid of these MD hashes. We could leave SHA in there if we wanted to, plain SHA, and plain SHA would give us some more compatibility for TLS v1 users. But when you generate your certificate, you're making these elections. When you create your certificate key pair, you're making the choice that you want a TLS hash, or you want a SHA-256 hash, or you want just simply an MD5 hash, which you don't want. Okay, so that's where I wanted to go into the hashing a little bit. And the other thing is, you're going to notice the newest numbers are very small. We're talking about 128 bits for the encrypted stream. But 128-bit encryption is actually extremely strong for what it is if you compared it to 128-bit hash, because the 128-bit hash is half as strong. And it's roughly equivalent to, I believe, don't quote me, but I believe that 128-bit AES is roughly equivalent to 2048-bit RSA encryption. And yeah, roughly. And then the 160-bit, there you're getting up to 384 or 3072-bit RSA. So we're dealing with different, when we move to elliptic curves, we're dealing with a different quantum. We're no longer talking about two prime numbers. So all of a sudden, the number of significant bits in the computation changes significantly. And there are tables of equivalences you can find on the web and under those NIST recommendations that I mentioned. So what is forward secrecy? And I believe Sandra pretty much covered this, but basically what we're saying is we don't want the packet before us to predict how we have encrypted the packet in front of us, and we don't want the packet in front of us to help reveal how you're going to decrypt the next packet. Now, in fact, we're not necessarily talking packet by packet, but short sections of a conversation. If you're going to use the same key for a year, which that's how things were 10 years ago, then breaking your cryptography means all I need to have done is to sniff the traffic, and I've pretty much deciphered everything your customers were doing for a year, if I've worked backwards from your server key. Now, it might take me 2 or 3 years to do that, given the so much computational ability. But if I have that, and I'm able to then decipher 3 years, or the last 3 years of that year of customer activity 3 years ago, it's a large problem. So we're going to use elliptic curve and TLS v12 in order to ask it to find unique values that are known only to the server and the client and are changing in an unpredictable way. The perfect, when you see forward secrecy and perfect forward secrecy, some people would like to treat them as equivalent. The definition that I've seen where perfect is applied is that you have no clue from packet to packet, whereas forward secrecy would mean we have limited the ability to transliterate from one to the next, but you might have a look ahead, having broken one packet, of being able to go through the next 2 or 3 session tokens and get some forward information there, but not a significant amount. So we're going to use ECDSA keys if we can for efficiency, but we'll fall back on this ECDH RSA keys. We're going to re-encrypt it with elliptic curve Diffie-Hellman and take our RSA key and recycle it for this new purpose. I'm going to come back to that. I'd like to take us to sessions, and I'd like to take us to the documentation on new session controls. So we have a couple things that we can do now using with less trust for our session store. It used to be that we would have a session cache, and that was basically 2 options there. You could have a session cache and remember all of the sessions going on to that server, either in memory or on disk. Or you can do a hybrid. I mean, most large deployments are going to actually use a RAM FS, and that RAM file system backs a cache file of all of the open sessions at the moment, with their expiry dates taken into account. So I can show you that for a moment. The problem is if you put it to disk, and somebody then has a backup from a few weeks ago, is able to put their hands on that collateral, if they can take that that particular file, they can then decipher all of the conversations that were going on right in that time frame, assuming they have access to the wire. So looking at the relevant documentation, we have a couple of controls that allow us to set this up. And the default, I believe, is SHMCB, the session cache. So we have the SSL session cache. That's going to tell us where we're going to store it. And as I suggest, you probably want to put that, a DBM file would be great as long as you put it on a RAM FS. Otherwise, you probably want to throw it into SHMCB. The other option is you can use a disk cache. You have to secure this very carefully, but you can have a single cache backing a number of front-end web servers, all of whom are able to resume the sessions from one another if they're sharing that session cache, if they know all of the session credentials in use at the time. But again, you need to store that in such a way that it's then trashed and you can't reproduce those conversations later on. Within that, you're going to want to choose a timeout. Now, if you look things like IE and IIS together, we'll tend to agree that 24 hours would be just fine. We're going to have one session for that day. And as I said, the most expensive part of SSL is going to be renegotiating what that shared session key is. So, okay, if performance is your biggest concern, let that sit for 24 hours, as long as confidentiality isn't important. But given that it's important in this example, we're going to recycle it every 5 minutes. So we're going to set that to 300 seconds that that particular session cache will stay alive. Now, what about an alternative? What if we don't want the individual server to have to keep track of that particular session? We have a large number of front-end servers. We don't want to share a session cache amongst them. In fact, we don't even want to remember the session. ourselves. So what has been introduced in OpenSSL 101 are session tickets. And what a session ticket is you have a, sorry, I'm going to try to get to, where's the example? So the consideration in a session ticket is, I don't want to be responsible as a server for remembering the session state. I'm going to make the client do it. This should sound very familiar to you if you've written applications built on cookies. I don't want to have to keep track of this. I'm going to send state information to the client and let the client bring it back to me when it's time. So a session ticket, what this allows us to do is to say, here is an encrypted packet. The client doesn't know what's in that packet, but they're simply told, set this aside, and when you'd like to resume your SSL session, give me this information back. Much, much faster than renegotiating a new SSL session. Much more straightforward and much less onus on the server itself if it has already thrown away that session information as soon as your connection was terminated. You no longer have to worry about that information spilling. So what we have in the new directives that you want to pay attention to is the SSL session ticket key file. And what that's going to let us do is say, this is the specific server key we're going to use to encrypt all of these individual session tickets that we hand back to the clients. Now, one of the obvious headaches here is that that must be the same key file amongst all of the servers that are going to respond to those session states. Because otherwise, server 1 is not going to be able to decrypt the session ticket that was created over on server 2 earlier in the day. So again, this is something that's still evolving, but we're going to want to be able to recycle this, and we're still introducing new features. Jeff was alluding to some patches that he has on certificate transparency. There are a lot of patches right now in the pipeline that haven't gotten back yet to 2.4, but you can expect a finer grain of control over the SSL session ticket handling in future releases. But this is already here today. If you read, there's some great blogs, and I'm going to run out of time here in not too much, so I wanted to point out some resources that you would do well to pay attention to if you're running very, very complicated sites. One of the nice things we have about social media is that social media people tend to be social. They tend to share their secrets and give a lot of information about what facilities they've used to best leverage what's going on in the evolving state of configuration for web servers. So Twitter has blogged this. I believe Facebook has blogged this. I'm trying to remember who all. But the list, GitHub has blogged this and pretty much described what they've done in order to share a session key amongst, or a ticket encryption key amongst a number of different forward-facing hosts. So you can get a lot of guidance and a lot of good ideas from their advice. Trying to think of other particular examples that are going to be very useful to you. Yeah. Well, it's a nice unicorn. So again, GitHub has written a good article on this, and I will be updating the slide deck with the specific citations so that you can kind of review some of these yourselves after the session. Let me think, what was the timing on this? We started at 45. We're due to end at 22. 45 and 30. So I have about 5 more minutes, and then I'll go through the rest of the slides to make sure there's an issue that I haven't touched on, and then we can take a couple questions. Another thing to consider now this has radically changed over the last 3 years is renegotiation. And very simply, anybody who's using SSL v3, renegotiation is fundamentally broken. If you let the client instigate a renegotiation, you end up with the ability to really break the sequence on what's allowed. There were various attacks. They were all focused on the same problem set of let's inject and turn off cryptography entirely by doing by having a man in the middle say, oh, here's one extra little packet, here's one extra instruction for you. So with TLS version 1.1, that all got refactored, and it was rethought out how a client can ask to change the SSL session. Or you have server-initiated renegotiation. Why would a server renegotiate? Because first of all, there may be areas on your website that you lock down using a higher grade of, you may use the SSL cipher list in a specific context where this app, that's company financials, we take them more seriously than the employee portal where they can change their picture and upload travel documents or whatever. So we're going to require a higher grade of encryption. And maybe they're on one of the older browsers, their session will be broken. But the server would like to make a seamless transition from the one to the other. The other thing is that you may want everybody to come in with a lower grade of encryption that's more efficient. But then when they get to that particular back-end section of the website. And then finally, they need to renegotiate because you've decided that you're only going to allow them to use that session for the next 300 seconds. So now that session is done, and it's time to begin a new session and change that. So renegotiation is really critical, but the only one we really trust is the server-initiated renegotiations and the very modern flavor of client-initiated renegotiation. OpenSSL project has changed this. They've changed the default to where they no longer allow pre-TLS version 1.1 by default. But different packagers have changed this behavior. I'd like to close with just a couple of minutes talking about encryption and how you can really spoil what is a good thing in terms of encryption. And what's happened is TLS compression sounds great, as does HTTP compression, because all of a sudden we're making the data smaller, and when you compress things, you tend to have data that looks more entropic. You've got a whole bunch of bytes, you no longer have predictability. The letter A and M and so forth no longer have a high frequency, and a lot of basic cryptography, a lot of code breaking doesn't work against this. However, they weren't really thinking about the fact that the TLS headers, or the compression headers themselves, introduce some very specific, very repetitive bit signatures to describe the compression itself. And the other thing is that most compression, like deflate, uses a dictionary. And in that, using that dictionary, they've made certain bit signatures occur more frequently. So if you have any control over the frequency of a set of characters in the content that's returned, you suddenly can you have a much higher possibility of breaking the cryptographic stream just by looking for known patterns. And one of the ways that we do this, either we put compression on it ourselves, or we're allowing reflection, where we're echoing what the user typed right back to them. This could be as simple as changing cookie values, so that we know that there's a very predictable cookie that will be in that stream, and we're going to simply decipher that packet in different ways until we can get to it. Deflation doesn't help us with this, and in fact can change things by as much as a byte to give us a sentinel to say we're getting closer to being able to crack that particular encryption. But the biggest design conundrum is the broken client itself. Anytime that you and I would like to have a secret conversation, we're going to agree on a key. We're going to agree on a way we're going to have an encryption. If I ask somebody else here, such as Sander, and I simply say, would you join this conversation? You two talk amongst yourselves. We're going to talk amongst ourselves. But we're going to share the very same SSL tunnel. So now I can observe the encryption of what I can predict, which is our conversation, and there is the other side conversation going on. If I can see that conversation, I have a pretty good chance of breaking that conversation too. And so where we are is breach is one of the newest defects. But what it is all of this entire class of SSL problems is that we're allowing JavaScript to run in session in parallel with the regular HTTP conversation. And so if somebody injects some JS and says, I'm going to put something very predictable and repeatable into this stream, and then I'm going to try to guess the keys, they're going to have a much higher chance of success. And until the browser designers themselves, we have very little control over this, decide that JS conversation with the server needs its own session ticket and its own cryptographic session, even in stream of the same pipe, we're going to continue to have this problem, and it's going to continue to evidence itself. So you can expect that we're going to be seeing some changes along those lines, both by browser designers and by the protocol itself as it evolves yet again. So as I said, the docs are your key resource, and I didn't spend as much time in them as I wanted to, but they just take note that not only are they changing, but there's a particularly nice feature added recently by our excellent docs team at the Apache project, where if something is not clear here, or something, when we get into OCSP stapling, which I couldn't cover this session, when we get into those directives and you can't quite make them out, or you would like some sort of overview, give me a simple example here, what you'll find is that we've added a comment system right to the docs itself. So feel free to push feedback at the docs page itself, particularly simple edits that you'd like us to correct. And the docs team, some of these may be reviewed more often than others, and different committers are more active than others in keeping up to date. But we would love to get these fixes in, and sometimes maybe it's not worth making a Bugzilla entry just to do that. So the docs themselves are a good feedback point. The users list, especially for general questions. The dev list, if you'd like to follow the activity of some of these patches that are being submitted and considered, and the activity that's happening on trunk. We'd love you to participate that way by picking up the fact that we're doing some new work and giving feedback if you in fact use those patches, because this actually guides us in terms of what we consider for backport to 2.4, is having enough, enough eyeballs, enough hands on the code to know that we should do that. Again, sorry for my own distractions this week, with respect to the 101G issues. But if you found a specific error in something I said today, or whatever, you can share that with me, and I'd love to hear about it, or share it with me after the presentation. These slides, but greatly expanded, will be growing at that particular URL. Please not only feel free to grab them, but also feel free to come back in a month and come back in 2 months. The final update to this slide deck is going to be at OSCon in July. So between here and there, we're going to be doing a lot of different consideration, plus 2.4.10 should be out by then with yet more features. So try to figure out how to deliver this in the allotted 1 hour. I'll take just a question or two. We're not actually kicked out of this room, I don't believe, because of but I know some of you want to get onto another session, so don't let us keep you. But are there any specific questions about the newer SSL features?
So we upgraded to 2.4.9 and noticed that it required us to add DH params to our certificate.
Mm-hmm.
I didn't see anything about that in the change line. So.
Okay, and let me think about that for a moment. You're talking about for your RSA certs? Yeah. Okay, let's just jump over to that particular piece of the docs. Oh yeah, okay. I'll let you do it. The observation was made that with the 2.4.9 upgrade, that the DH params are now required to be specified when you're loading your SSL certificate files. And I should note, the other new introduction in 2.4.9 is that you want to actually now nest your CA list, all of your dependent certificates, in the same SSL certificate file so that they can be walked backwards. And we used to have this SSL CA certificate file directive separate and apart from. What we'd like to do is now encourage you to consolidate. Here's your certificate. Here are your parent certificates. Here is not your root certificate. You can't put the root certificate in there, but you put all of the certificates between a trusted root and your specific cert into the same cert file. So with respect to the DH params, I'm going to see if I can find something unless, is there somebody who can more quickly address that question than I can? As far as the 249 delta? So additional options, elements, and the EC names. So if you weren't running on 101 and you didn't enable EC certs, the EC DH, key handshake, I don't think you're actually required to do that, but this is a callback from OpenSSL that we react to. And what can I tell you about that?
Yeah, so we're running 098F, and we don't have, we don't support DSA or anything like that. So.
Oh, it's prompting you anyway?
Yeah.
That sounds like a bug.
Okay.
That
We
sounds
just
like a bug.
upgraded on Friday, so I haven't had a chance to research it that much.
Well, check your 098 and just make sure using the OpenSSL ciphers, see if that particular cipher is in the list. Or you can use some of these online tools, such as I was going to mention Qualsys.
Oh, yeah, we use that.
And it'll tell you the list of certificates of protocols and ciphers that you're permitting. And if you see an ECDH there, well, clearly now it's legitimate that it's asking you for that.
Right,
I didn't know that
in our situation, it's back end, and we can't actually reach our servers from the internet. So
that can be frustrating. I think at least one of them actually has a tool you can download.
Yeah, SSL scan is a command line tool.
The other thing you can use is OpenSSL space S_client, and you can ask it to be incredibly verbose about that handshake.
Right.
But I think you can actually dump virtually everything, including the entire list of supported ciphers. I think you can spit those out using the right args. It might be as simple as a -VVV, be extra, extra, extra verbose. Other questions? I saw one more hand up in the back on the left. So I'm sorry I can't give a good answer on that DH params. If you wait just one second. But we do make mention of them. We didn't call them out in changes. We do make mention of incorporating that. And I hope we provide an example. Here we go, beginning with 247, yes. Another change. Okay.
So what are the plans to update the configuration files to reflect a lot of these new improvements? Are they already changed? Or because a lot of people are not going to go through all the documentation, they're just going to use whatever is there.
Some of the changes are in there. Again, what we're going to do with the OpenSSL or with the HTTPD project is make the most flexible configuration for you. We're going to be as permissive as we can in general. And so your default HTTPD conf and HTTPD-SSL conf are going to be tuned and tailored to accepting all of the existing browsers that are still in circulation. I should say that there have been a couple surveys, and I'm trying to remember whose I'm thinking of, who went ahead and actually made a survey of which TLS SSL. Do you recall the particular survey I'm thinking of? Which ciphers are supported by which browsers as of which version? Somebody's started a survey effort on that.
I don't remember what that is.
I'm fairly sure, and I'll append that to the slides and give you that. So if you look later in the week, I should have a list for you. So we're gonna try to maintain flexibility. Certainly the DH, for example, probably should have been covered. And again, we need the feedback. So both the docs site itself and the users list are good ways to get that to us. I'm trying to think, did I thoroughly answer your question? I might have retracked to the other question. Okay. All right, well then, great. Thank you, everyone. I appreciate your attending, and hope you got something out of this, and look forward to further refining this and getting, like we were saying, some more of this information back into the docs because it's evolving so rapidly. We as programmers are not doing a good job of keeping up with the changes to the documentation. as it happens in real time.